OK， 来我们开始。OK， waves 啊 ，Chapter 5啊 ，waves。Light 我已经讲完了，可是我也是会回去讲啊，也是会回去可能讲一点东西。After I finish wave 啊。Okay, so we're going to start from the beginning. Okay, waves, because some of you haven't learned about it, and some of you have already learning it. Waves. So I'm just going to start from the beginning. Okay. Now, waves are. So what is a wave? Now, by the way, first understand what is a wave. Now, wave is when I talk. Let's say when I talk, I'm using my energy. Okay. Now let me draw this out. Okay. Let's say this is me. Right. Now, when I'm talking, then I'm using my energy to create a vibration. Okay. Now, first thing you have to understand vibration. Vibration, oscillation, 或者 disturbance. They are all very, very similar. Okay. So when I'm talking, then I'm using my energy to create a vibration, meaning that the particle just in front of me, it vibrates. Okay, this particle in front of me, it vibrates maybe up and down or left and right. Okay, so this vibration will travel. 这个 vibration 它会 travel it will travel through a medium. All right, through a medium, and it will reach maybe someone's ear or anything. Okay, so that's how they hear my voice. Okay, so the key point is that the vibration, it will travel. Okay, it will travel in a specific direction. Okay, now, so if you look at this simple scenario, it all started from a source. We need to have a source. It's the source of the vibration. So in this case, 我在讲话是那个 source is coming from my vocal cord. Okay, 我的喉咙啊 okay, vocal cord. Okay, so this is the source of the vibration. Now, source produces this vibration, right? So vibration. Now, vibration, the thing about vibration is that it carries energy, right? Because the particle is moving, so it carries energy. Okay. Now, carries energy, and then what happens? So this vibration, it travels, right? It travels. Okay, and then it reaches its destination. So destination here. Okay, whatever is the destination. Now, what happened is that during the travel, they will create a certain pattern. So this vibration and the way they travel, they create a pattern. It's kind of like the way they travel, how they travel. They move in a very specific pattern. And this pattern, we call it a wave. Okay, this pattern, we call it a wave. So what is wave? Wave is actually the propagation of the energy. Propagation means traveling. Okay, how the energy is moving from one place to another place. What is the pattern that it is moving in? That is we call a wave. All right. So a wave carries energy because the vibration is energy. Vibration is energy. Now, later I'm going to talk about in more detail. So how does the wave happen? Okay, now maybe you're asking, so 如果讲是 wave is traveling in a pattern, right? So what is the pattern? What is this thing? What is this thing, this pattern? All right. Now, pattern, think of it like this. Okay. Imagine 你拿一个很长的绳子 ，OK， 很长的绳子，然后你 fix 右边那边去一个fix wall, you fix it here, okay. Now, let's say you're holding the left end, and then you do a very quick up down movement, okay, very quick up down movement, okay. So what we'll see is that you are okay. What are you doing here? Why? First of all, what are you doing here? When you do a very fast vertical and up down movement, very fast, you are creating a disturbance. Okay, you create this disturbance or vibration. Same thing. It's the same thing. Okay, you create disturbance here in the particle, in the rope. Now, this disturbance again, it will travel. This disturbance, it travels. So how does your rope looks like? It looks like this, okay? It travels like this, like a wave pattern, okay? So this is the pattern it makes, This is the pattern it makes. So this is, we call it the wave, wave, a pattern that made by the traveling of a disturbance, okay? So number 2 is that travel, and number 3 is create a certain pattern, okay? So this is just a basic analogy of the wave, the pattern of the wave. Now, the problem is that okay, pay attention to the keyword disturbance 这种你都是要用到的那种 keyword 尤其是在那种考试essay 你们就不要用到那种 term disturbance vibrations 那种 OK。那接下来是 OK， 我们讲 how does the disturbance travel how does disturbance transfer OK， 你 imagine 是如果这个是那个绳子这个是绳子这样子。那如果你 imagine 它 OK， 我们放一个 point 这边，把它当做是一个 particle 在这个绳子。那如果你推这一 part 上去 ，imagine 你推这一 part 上去 ，you are pushing it up from this end， so the rope will look like this， Okay, let's say you're applying your finger is over here, you're pushing it up here. So this specific particles is over here, right? This specific particles. Okay, now, meaning that you are disturbing this particle, you are moving it up, right? So what happened is that the neighboring particle, just beside it, the neighboring particle will also moves up. Okay, why will the neighboring particle moves up? Because of, in chemistry, you learn about the intermolecular forces, right? You learn about the forces between the atoms or the particles. Okay, meaning that when you disturb, 当你 disturb 第一个 particle 因为那个 intermolecular forces between the next particle and this one, this disturbance will, the first particle that is being disturbed, it will disturb another particle, the next particle, okay? And then the next particle, it will also disturb the next particle, another particle, and this will keep on repeating, okay? So this is how the disturbance is traveled, because you disturb the first one, and then it disturbs the second one due to the intermolecular forces. OK， 所以如果我放第三个、第四个、第五个 particles， 所以如果你看这里全部都会 ，it will rise. OK， you push the middle region, it rises, but the neighboring particle it will also rises. OK， so it's kind of like this whole thing will slowly all until here will also the particles will also rise. So this is how the disturbance is transferred, okay, from one point to another point. Now, okay, so this is the vibration. So now if you look at one particle here, the first particle that you disturb, I'm going to box it. This particle, it vibrates, right? It vibrates. Now, what is vibration actually? Vibration. It's not only moving, okay? It has a specific criteria for vibration, okay? A vibration particle, it means they move to and fro. Remember this word, to and fro, about a position, okay? Like an up-down movement, or it can be a left-right movement. So a to and fro movement. Now, why does the particle vibrate? First thing, why does the particle will move? So the particle in the rope, it will move up, and it will move down, and it will move back to the original position. 就好像这样子 ，OK， 这个是你的original. We call it the equilibrium, the equilibrium positions. So at first it moves up, you push it up, and you down, and then come back here. Now, what causes vibration? When you push it up, right? Again, what forces is there? Intermolecular forces 所以你把它推上去的时候是，同时它会有一个 restoring forces， 意思说它会有一个restore for 一个 force 会 restore it back to the original position. Okay, I draw it in the red arrow like this to move back down. Okay， 就很像之前我们学到的那种elastic potential energy. Okay， 在 string 里面当你 stretch 那个 strings 里面会有storing energy. Okay, the restoring force, it will pull it back to the original positions. So that is the thing that causes the vibration. Okay, because when you stretch it, you disturb it, due to the restoring forces, it pulls it back, and this motion will repeat. All right, this motion will repeat. So it go up, down, up, down, up, down. And this one, I'm talking about one particle only. Okay, one particle, the one that you push. Huh? Okay, so the first particle will do up-down movement, and it will transfer this movement to the next particle. The next particle will repeat the up-down movement, and it transfer again to the next one. So this is how the disturbance is transferred. Okay, this is how the disturbance is transferred, just to give you a picture of it. Okay 啊，那同样的 ，so particles 它们 vibrate 上下，可是你会看到那个 wave 是从左边走到右边 ，right? The wave is traveling. Yes, you see a wave is traveling, just like when you flick the rope, you see that the wave is traveling, as if it is moving from left to the right. But the particles inside the rope, the particles inside the rope is not moving. They are only moving up and down. It is not moving from left to right. Okay, so the particles, they do not travel. They just moving up, down, up, down. Okay, 所以如果你把这个绳子你 mark 一个红线 Okay, back to the diagram here. This diagram down here, the bottom left. 如果你 mark 一个 let's say you do a red mark lah, here. Okay, you do a red mark here. On this string here, over here. You do a red mark here, and you observe when you flick the rope, you observe the movement of this red mark. You'll see that this red mark is moving up and down, right? Up and down. So it's kind of like this. If I sketch the whole vibration, it looks like this. So the green one and the blue one, like this. Okay, so the red mark is going up and down in the same direction. So this proves what? Treat the X mark, treat the red mark as one single particle. OK， 把那个红色点当做一个 single particle。所以如果你这样子，你做一个 wave 在那个绳子上面那个 particle 你会看到它是走上下上下，它不会 displace。We use the word displace, meaning that the particle will not move away. Okay, it will not move away. It only vibrates at its original position. What is moving? The wave is moving. Okay, the wave is moving. So that is one of the properties of the waves. So this key point here, okay, you can write down somewhere. Okay, particles not traveling. The disturbance is traveling. Okay, particle is not traveling. Only the disturbance is traveling. Okay, so if you see this one, this scenario here, there are two types of motion, right? So there are always two types of motion in a wave. Remember this one. Okay, the first one, it is the propagation of the wave. Okay, so propagation means the traveling of the wave. And second, that is the first motion. The second motion is the particle, the motion of particles of medium. Okay, and the motion, it vibrates at fixed positions. 就讲那个红点，我们刚刚讲到的 ，okay, it only vibrates in fixed positions. Okay, so there are only two types of motion in a wave. First is the wave motion. Second is the particle motion. You have to be careful this. Okay, sometimes people get mixed up with these two. Wave motion 跟 particle motion 是不一样的东西Okay. So motion of particles of medium, OK， 所以在这个绳子这个example the medium 就是那个绳子OK，the medium is the rope. The wave is traveling using this medium, OK。如果另外一个 example let's say 你丢一个石头进一个水大海 ，right？ You will see ripple, right? Ripple, kind of like the all these water waves. If you drop a stone in the ocean, you see these ripples, okay, small waves. Now, the moment you drop it, it produces what? The first thing, you drop it. It produces what? Again, disturbance. You start with disturbance, okay? We start with disturbance. So you drop it, you create disturbance, and this disturbance we call it a pulse. 如果你的 disturbance 只是好像没有，比如说你这个 example 啊，如果你丢它下去是它没有 wave 啊，它只是 boom 这样子一次罢了啊，你的 disturbance 只是一次罢了，那个我们叫做 pulse。OK，pulse P-U-L-S-E pulse 意思说一次罢了那个disturbance， 一丢它 boom， 然后它没有了。OK， 那如果这个 disturbance continuously flowing like ripple like water waves or ripple then we don't call it a pulse. Okay, we don't call it a pulse 如果是一个 disturbance only we call it pulse. Okay, so if continuous disturbance then what do we call it? If continuous disturbance we call it the wave. Okay, the continuous disturbance again you can call it a wave. So in this example here, what is the medium? The wave is traveling through water, right? The wave is traveling through water. So water is the medium in this case. Sound wave, yes, medium 就是 air, 因为 sound wave travels in air, right? It can be air, it can be solid or liquid. So water waves, okay, water, medium. 所以需要 medium 来 travel the wave 呢，我们叫它 mechanical wave. Okay, 有时候你会看到这两个mechanical wave. The first one, this one, mechanical wave 呢，就是讲需要 medium 来 travel 的，需要 particles 的。Okay, sound wave 啦，what else? Yeah, so far it's only sound wave. Yeah, mechanical. There are of course there are many more lah. Okay, so one example is sound wave. Sound wave it needs particles to travel. That's why in vacuum you cannot hear sound. The second type of wave is we call the EM wave. Electromagnetic. Okay, 就很像 light wave gamma ray X-ray all that. They don't need particles. They can travel in vacuum. Okay, two types, two general categories of the wave. Okay. Okay. Now, so propagation again. Propagation, just to remind you, propagation it means the way the wave moves. Okay, or the traveling of the wave, because it's called the propagation. Okay, so you just have to get familiar with the terms. All these terms over here. Okay, so next, I'm going to erase this one. Now, talking about vibration, 刚刚我们讲the particles. So let's zoom in one particle. There's only one particle. Okay, let's take the same example. The rope. Okay, vibration or oscillation, meaning that we take the initial reference point in the initial position of the particles. Let's say this one, we are going to take up-down movement. Okay, up-down movement. So first, it goes up, and then comes down, passes the equilibrium positions, and then back to the equilibrium positions. This is we call one vibration, one oscillation. And the repeated movement of this one, then that is vibration. Okay, so you can see this one happen in not only particles, strings also. Okay, and pendulum. Okay, previously you did experiment for pendulum. Okay, so here's your pendulum, and here and here. All right. So one oscillation means starting from the original position. So let's assume that the original position is at the left. Okay, so it flows down here, up here, and all the way back here. This is one oscillation. Okay. Now, oscillation can be a spring. Okay, spring. So we have a spring here, hanging any random object here. So the equilibrium position is before you stretch the spring. Before the spring is stretched, the distance, the position of the object. So after you stretch the string, and then you see the object vibrate like this. Up, down, and come back. Okay. Now, 如果你看这个3个 process， 一个 point， 第二个 point， 第三个 point， 我 mark 那个 x。So one oscillation or one vibration 是，你一定要拿 the particle must be at the same direction as its original motion. OK， 什么意思？比如说你拿 OK， 我们看第三个 example。So 一来它是走上嘛，对不对？一来它是上前 ，OK， 它是上，意思说这个是它的 initial original direction。OK， 它走上啊，过后它下来是在第二个 point 啊，在第二个 x 这边呢，我们不可以讲它是 one oscillation， 要小心啊。OK， 这里是不是还没有到 one oscillation？One oscillation 呢，一定要它回来，向着它本身向着的地方这样子走。OK， 就是一来它是上嘛。OK， 所以它回来了，然后它再回去那个原点子，它是走着上面的，只是它是向着上面来走。OK，so that we can only say that it is one vibration. So meaning that this one vibration is a to and fro, then back to original position. This is the first criteria of vibration. A to and fro movement, and then back to the origin. It must go back to the original position. Only we call it one vibration. And second is that the current direction, it must be the same direction as the original motion. Same direction as original motion. Okay, so meaning that if the pendulum, you count from the middle, let's say after it reaches the middle, and then you calculate. So the initial direction is moving to the right like this. Okay, and then it flows back to the other side. Okay, and then come back here. So this point is the same original position, and also it is facing to the right. It's same as the original direction. So only we can call this is one vibration, one oscillation, one complete oscillation. Sorry. Okay, one complete oscillation. Okay, one complete oscillation. Okay, now 接下来是你们要知道 ，Okay, what is a phase? Okay, let's take the first diagram 最上面那个 diagram. Now, if I draw the motion of this particle, okay, use your imagination. This is the particle, so it moves up, down, and back up, right? So if I draw the particle movement, so it looks like this. Up, down, and like this, right? So the x-axis is the time axis, or you can do it second or anything. Okay, so the y-axis is the displacement axis. Okay, so this shows the movement. Okay, think of this as the movement of one single particle. Okay, now you have to understand the word phase, because phase you will always see it in everywhere. Okay, phase. What is phase? Now phase is, it says a fraction of a complete cycle. Okay, you can think of it like a fraction of a complete cycle, or you can say that a phase is a current position in the cycle. A current positions of something, STH something. Yeah, the current positions, just a current position in the cycle. Current position in the cycle. Okay, meaning that the current positions of the particle, like happening now, this second, this instant of time, where is it? Where is the movement of the particle? Is it over here? Is it over here? Over here? Okay, and phase is measured in degree. Okay, phase 我们用 degree 来 measure， 就是这里是 this one over here is 90 degree, this is 180 degree, this is 270 degree, and this is 360 degree. Okay, or sometimes we can use the radian. Okay, 90, 180, 270, and 360. So meaning that if I ask you, if I ask you, where is the particle right now? You have to use the degree to tell me where is it currently at. Okay, so you can think of it like a fraction. It's just a fraction of a complete cycle. This is one cycle over here, one complete oscillation, one cycle. So the current positions of the particle in the cycle, is it at 270 degree here, or is it at 90 degree here? That is the phase. Okay, the phase. Okay, so in short, 还有一个东西很重要，就是不只是它的 position 还有我们要讲它的 direction 它的 direction 也是。OK， 比如说你从这里开始0度那边全部人看0度它的 direction 是它的 particle 开始走上去，对不对？OK，at 0 degree here. So it moves up, right? It moves up, and then until 90 degree, it starts to move down, right? It starts to move down. 然后在这边它走下来。OK， now 继续 passes through 180, and here it moves down, and here it moves up. Now, what is the meaning of in phase? Sometimes you see this word. In phase. 比如说讲 particle A and particle B, they are in phase. Okay, now remember for two particles that are in phase, they must have the same position and same direction. Same position and same direction. Okay, look at the graph above. Where is same position and same direction? Same position is over here. Okay, now let's say I take this particle over here. Let's call it particle A. Okay, particle A. Now, at this current instant of time, it is moving up, right? It is moving up and the position is at 0. Right? Now, you can compare with another particle in the wave. Another particle, say the particle is over here. This one. And we call this particle B. Okay? Now, look at particle A and particle B. Particle A 是在 the equilibrium position, the x-axis. Particle B 也是在 x-axis. So they are at the same position. Okay, they are at the same positions. So they are at the same positions, and look at the movement of the particle. A is moving up at this point, and B is also moving up. So we say that in this case, A and B, they are in phase. 因为他们在 same positions and same direction, so they are in the same phase. They are in the same phase. All right. So think of phase, not only in terms of the position. Think of phase in terms of positions and the direction. Where is it currently moving? Okay. 所以如果我加了一个 particle，let's say 我加了一个 particle 在中间这里，然后这个是 C。这个 particle 呢，在这一秒它是走着下面的，所以我们不可以讲 C 是跟 A in phase No, they are not in phase, simply because the direction is not the same. Okay, only B and A, they are in phase because they are in the same current state of movement, of motion. Okay, so that is in phase. Make sure that you understand what is the meaning of in phase. Okay. So if you look at the first, example, the rope, right? So you have a rope and then you flick it, right? You see a wave like this. So what you'll see is that you do a red mark here, right? You do a red mark here, and you see that the red mark is vibrating, right? And then you see along the wave, along the wave, some point in the wave, you'll see there are many particles that is also in phase with the red one. Okay, as the red one moves down, some of these particles also move down. As it moves up, it also moves up, and they are in the same location or direction. Okay, so a structure of the wave structure, you can find many particles that are in phase with each other. Okay, so this is in phase, this is in phase, this is in phase. Okay, now I just want to show you one a simulation. Okay, I want to show you a simulation of this one. Okay, let me just bring this up. wave on the stream. Okay, 来看这个。Okay, I'm going to put no end. Slow motion. See. Okay. Now observe the wave movement. Observe the wave movement. Okay, observe the green particle, the first green particle, this one. Okay, now you can see all the particles, they are moving up and down only, but there is a wave particle, there's a wave motion moving to the right. Because you remember what I said, there are two motions, right? 还有两个 motions for a wave，一个是那个 wave movement，第二个是那个 particle movement. Okay, two motions. Now, so if you can see from here, which two particles they are in phase. Okay, meaning that they are moving the same exact direction and they are exactly the same positions. Okay, I just pause it. Like this is very difficult to see. If I pause it, okay, so you can kind of see which two particles are in phase. Okay, again, look at this one. Look at this one. Okay, look at 看这个，还有这个。Okay, the first one and somewhere here. Okay, all this, one of this. They are moving in the same, okay, when I pause it, they are at the same location and they are moving together also. Okay, they are moving together also. Okay, let me just play it. Okay, focus on that two particles over here. Okay, so same thing, it is moving up, down, together at the same time. So these two particles we said that they are in phase. Okay, they are in phase. So there are many particles in phase in a wave. Okay, now, so next one. Okay, so can be some of the particle can be this one, or this one is also in phase. Okay, if you look at somewhere this particle over here, and also this particle over here. Okay, now this one over here. This particle is at the equilibrium position at this point in time, and it's moving up, right? It's moving up. And this particle over here, also it is at the equilibrium position, and it's moving up. Okay, 所以它的 position 是什么？如果我们用 degree 来讲因为 phase 通常都是用 degree 的嘛 ，OK， 它的 position 就是在 zero degree 0 degree。0 degree 如果它上到去上面呢，就是90度嘛 ，right 90度，因为这里是90度，它下回来 0 degree， 然后180度 ，OK 180度，再下270度，然后再回去又0，又从头开始 ，OK 又0又90，180 270又0 ，OK， 所以这个两个你可以看到它是they are also in phase because they are moving up at 0 degree. This one is also 0 degree and they are moving up like this. Okay. Okay, 我会再create那个link，我们再 join 多一次，剩下1分钟。